Hello again. Welcome to Samved, a grand hackathon of this year. Samved is a joint initiative by MIT Vishwaprayag University and Solapur Municipal Corporation. I, Preeti Baligar, will just walk you through the early stage solution architecture, which is a third video in the series. If you haven't seen the problem definition articulation, you can go back to the previous video. You are already aware of the entire process of the hackathon, which begins with the registration on 9th of February and goes all the way till April 15-16 for the final in-person contest at MIT Vishwaprayag University, Solapur. As shared earlier, the specific focus of the third video is on the idea submission stage, whose deadline is 20th of February. In this video, I shall share with you the expectations for the early stage solution architecture. The requirements for problem definition have already been shared with you in the previous video. So here I present to you a few other details of the hackathon and its process. Our specific focus is the item 4, idea submission phase. You can visit the portal for the general guidelines of submission of ideas and the evaluation criteria. We shall now go through the early stage solution architecture and the expectations for the idea submission stage. Please note that the expectations and the templates will be available on the website and its deadline is 20th Feb. So what next after problem definition? In this step, we will develop the solution architecture early stage by breaking the system into subsystems and defining their interactions so as to meet the user requirements. Please note that your proposed solution is a complete system of interest. It must fully satisfy the earlier identified user requirements, which is generally happening through interacting subsystems. Therefore, you will identify the subsystems, clearly define their boundaries across the subsystem, and identify any flows crossing them like energy, material, data and/or spatial elements. These subsystems can be existing, example off-the-shelf components, or maybe newly designed. Wherever possible, you can reuse subsystems for practicality. Let me now take an example of the bottle capping machine and lead you through the early stage solution architecture. You are already aware of the cafe that prepares fruit drinks and stores them in bottles. And the owner now wants to automatically cap the bottles so that the cafe loses less time. For this, we have articulated the objectives, the constraints and the functions in the previous video. The consolidation of all of these would represent the problem definition. Now, taking this problem definition as an example, we will go through the early stage solution architecture. Let's begin. This table lists the subsystems comprising the high level or early stage solution architecture for the automated bottle capping machine. It decomposes the entire system of interest into 5 subsystems. Each system has a singular focus, which is shown here. Now, the conveyor belt focuses on transporting the bottle sequentially through the process. The bottle detection unit senses bottle position to trigger next actions. The cap feeder or the hopper supplies caps one by one. The capping mechanism applies caps via presses, screws or pistons. Finally, the control unit sequences the operations and handles the logic. You would also need to identify the subsystems for your proposed solution. Here we see the interface matrix for a bottle capping system, which explicitly maps all the flows between the subsystems. The rows and the column headers show the subsystems and the cells depict the kind of interaction that the two systems have. On the nutshell, we see that there are 3 kinds of interactions, either data, material or spatial. In engineering design, spatial interaction refers to the functional and physical relationships between components or systems. They typically describe how various parts interact physically. The conveyor belt interacts with the bottle detection sensor and the capping mechanism through physical interactions, whereas it passes or receives data with the control unit. Similarly, the bottle detection sensor interacts with all other subsystems through data interactions only, whereas the cap feeder and hopper interacts with the capping mechanism because there is a material exchange and there is some data flow with the control unit. Here you see the remaining two subsystems, capping mechanism and the control unit, and their interactions with the other corresponding subsystems. For your solution architecture, you will be submitting to us an interface matrix depicting the interactions and flows between its various subsystems in a tabular format. This early stage architecture diagram of the bottle capping machine refines the bottle capping system into layered subsystems by improving modularity and by separating concerns like control, material flow, power, and so on. This image is definitely AI generated, but for your submissions, we would like to assess you on the interaction matrix that I showed to you previously. This diagram is purely optional and will not be assessed, but it depicts your architecture diagram with better clarity. The previous example that we saw of the bottle capping machine was a mechatronic system, and therefore its subsystems included sensing, control, and actuation. The next example that we are now going to see is of student management software, which I have conceived to be purely a software system. You are already aware of the problem definition for the small coaching institute, and we have seen and discussed the objectives, constraints, and functions and its problem definition as well. We shall now architect the early stage solution for this particular problem. Just like the previous subsystems breakup, here I am showing you the different subsystems for the student management software. Please note there could be several other subsystems. What I am showing you is just a representative list. The user access layer, handling the user views, the backend API, processing the business logic, authentication, and the typical CRUD operations, the database which manages and stores data, the payment gateway for processing fees, as well as the report generator which computes and exports daily, monthly, or reports or SMS. We shall now see the interaction matrix for these subsystems. Again here we see the different subsystems listed in the rows as well as the columns. This interaction matrix shows how the different subsystems interaction with each other. In contrast with the mechatronic system of the bottle capping machine, all interactions here are data, and the type of data that is flowing between these subsystems is listed in the brackets. This is the remaining part of the two subsystems. Finally, we come to the visual representation of how the different layers interact in a layered architecture diagram. As stated earlier, this image is AI generated. You may submit this for better clarity, but we will be assessing you on the interaction matrix that was shared with you earlier. Here, the different arrows show how the API calls, database queries, reporting, and notifications flow through the entire subsystem and which subsystem interacts with which other subsystem. You may submit this as well. Finally, we now come to this evaluation criteria for both problem definition and solution architecture. Here we see the evaluation criteria for the idea submission stage. Your submitted idea will be evaluated for 100 points, with 50 points for problem definition and 50 points for solution architecture. Under problem definition, you will be evaluated for problem framing and context, objectives, constraints, and functions identification, and followed by the relevance of the objectives, constraints, and functions to the problem statement. Second, the solution architecture will be evaluated for identification of subsystems, subsystem boundaries, and subsystem interactions. While you can submit the architecture diagram, please note that we will not be assessing you for the architecture diagram, but you may submit it for better clarity of the solution. In this video, we shared with you about the expectations for the early stage solution architecture as well as the evaluation criteria. Please note the last date for your idea submission is 25th February and templates are available on the website as well. With this, on behalf of Team Samved, I wish you all the best. Thank you.